All attendees are in listen-only mode.
Good afternoon, everyone. Welcome back to the webinar series for the LI. My name is Lauren, and I am the Events Executive for the Landscape Institute. This afternoon's webinar is on verge biomass with Dr. Nick Cheffins. As you can see in front of you, hopefully, it is a feasibility study into the utilization of anaerobic digestion to sustain the harvesting of road verge biomass. So how to make money out of grass cuttings. There we go. So I will pass you over now, as it is 1 minute past, and most of you should have logged in by now, to Nick. And by the way, I will monitor the question box. So if any of you can't hear me or are having audio problems, just let me know and I can see what I can do there. But don't panic if you can't, because remember, this webinar is being recorded and it will be uploaded onto YouTube shortly after today. So with that in mind, hello, Dr. Nick Cheffins.
Hello from Lincolnshire. Thank you very much for inviting me to become involved in this slightly out-of-body experience, and I hope we find some interest in this presentation. The background to this is that we've been involved now for a couple of years in looking at how we might use what we've called low input, high diversity biomass as a way of distinguishing it from energy crops and other farmed byproducts as a feedstock for a range of renewable energy technologies. And amongst these is anaerobic digestion. As I'll mention a bit later on, we've been in contact with projects that are looking at other aspects of this right across Europe, and there is a significant volume of activity beginning to occur the other side of the channel, and now quite a lot suddenly starting to happen here. Our standpoint is that something that's sort of perhaps a grass-dominated herbage and harvested through a variety of ways, some of which will be quite familiar to farming operations, will produce an inside biomass that we believe could be used as a feedstock for anaerobic digestion. And the interesting thing is there's a number of pushes that are beginning to make this seem more and more relevant. We've got issues for national governments, such as their discussion now about what they see as the avoidance of the displacement of food production or an indirect land use change by renewable energy crops. Although I would say that some of the statistics don't really back that up, in that the amount of land that's being taken for renewable energy crops as opposed to food or other uses is really still very, very small. But I accept it could grow. You've then got emerging policies like the National Pollinator Strategy, and the reason that we think that will work is that taking biomass from things like road verges, as opposed to mowing and leaving it as a mulch, may well actually promote biodiversity, and there is some evidence here in Lincolnshire where that is the case. We have a project some of you will probably, I'm sure, be well aware of, called Life on the Verge, and that's where we've been using harvest systems to take grass off road verges, and over the years that's been practiced, the biodiversity of those verges have improved. And in fact, here in Lincolnshire, where we plough more land than any other county in Great Britain, in some cases some of the limestone wildflower species are really only found on road verges now, or largely on road verges and nature reserves, whereas they should be far wider spread. So there's another bonus here, which is not just perhaps making money out of road verges, but the real one is about improving the support that you can get from a more biodiverse environment. There's another group of drivers that are also pushing this. Local government needs to save money under the current austerity regime, and if it could reduce the expenditure on its verge management, it would be quite interesting to do that. And it sees one of the possibilities is to try to realize value from those cuttings as a biomass fuel, but perhaps as biomethane from AD. And interestingly, there are a number of other near market technologies, especially around what they call thermohydrolysis, that could also use this material, perhaps produce things like bioethanol. So the interest in fuels from green infrastructure situations could well be starting to increase. We already have come to the conclusion that the cuttings will probably have to be mowed and harvested in one operation to minimize disruption to traffic flow and to maximize the safety of the process. And that's in some cases a bit different to what is current farming practice for biomass harvesting. So there's some interesting little challenges to actually get that to happen. But in terms of the size of the opportunity, Department for Transport statistics sort of shows that we've got something like 400,000 kilometres of road, of which probably 60+% is classified as rural and likely to be dominated by soft verge margins. We think that if we look at that, we're probably means we've got about 500,000 kilometres of rural road verge, and depending on how you interpret some of the preliminary research, it is possible that that may well yield somewhere between 600,000 and 2 million tonnes of fresh material a year. That depends on a whole range of factors, and some of those I'll mention later. So here in Lincolnshire, we've got a couple of road verge types. There's an awful lot of this sort of road verge. Thinnish grass, but actually quite a good resource for AD. This is one of the preliminary sites we've been doing some test work on, where the area there, if my arrow from my mouse is showing up on your screens, is about 1.2 meters wide, and it's the strip that is cut 3 times a year for standard road verge maintenance. On the other side of my rake that's leaning up against the marker there is about another 0.8 of a meter, which we asked the guys to cut for us as well. And we harvested grass from this to look at some of its characteristics. And we split the 2 harvests, and interestingly, although it doesn't look a lot different, this side was yielding 4 times as much fresh weight as that was. If you come down here, to the second picture, another road verge, a common type of road verge in Lincolnshire and many other parts of the country, with the 1.1 metre wide strip mowed and the next metre or more not mowed. And in that metre you've got a terrific crop of cow parsley. That was taken late May, early June, and the keck in full flower, and it probably would yield near the 5 tonne per linear kilometre fresh weight that I mentioned earlier in those aggregated national stats, and it could well make a good feedstock for anaerobic digestion. One of the things we've been doing therefore is having a look at Lincolnshire, and this is one of the result tables that's already coming out. You can see Lincolnshire covered in huge circles. These circles they've got numbers at the centre. I don't know whether you'll be able to see that clearly, but I'll make sure that we have our report available later on this week or early next week, and you can see this in a little bit more detail. At the centre of each of those circles, therefore, is an anaerobic digestion plant, and most of the ones here are plants that say they use a proportion of grass within the plant, so they could be of interest to us in terms of utilization centers for road verge material. That's a 20 kilometer radius circle around the plant, and so you can see that the half dozen plants there are covering quite large areas of Lincolnshire. That's not an exclusive set of plants. There are other plants around that I hadn't included. We've just put some of the bigger ones in here. We chose this based around some work that was reported from Southampton University, and they had done some analysis of harvesting, which showed that that operational hexagon with a 20 kilometer radius could provide sufficient biomass to drive the cutting, collection and processing of the verge material and produce a substantial energy surplus. and what they did was a two-stage cut. So between about May and the end of July, they cut trial areas twice. They based their data on an actual verge harvesting trial carried out in 2006 in Powys in central southern Wales, where in this trial they first uncovered the variability of the yield, and you could see how in terms of dry matter the yield varied between about 89 and nearly, or between 90 and say 300 kilograms of dry matter per kilometre. So quite a big variation in the dry matter. And as I said, that's the application of this to Lincolnshire. The table, which you'd see more clearly in the actual report, gives analysis of how many kilometres of road, how many hectares of road verge was available. It also, at our request, looked at another asset within Lincolnshire that's quite important to a number of parts of the county, which is our inland drainage network. So our inland drainage boards also look after quite a large amount of linear infrastructure, and they have to cut that as well. So we started to look at that in addition. So what we then did was to look at a performance model, and here you've got those 6 codes for the 6 AD plants. We looked at the kilometres of verge here. We rounded it to 80% because we took a view that at least 20% of those verges probably wouldn't be accessible. Arbitrary, I know, but it was based around walking around a few verges. And we recognised that you've got areas that either they were too narrow, issues around road furniture where you couldn't get a harvester in, and also, as in one of the slides I just showed you, the second of the 2 slides of the road verges, if you look closer on the right hand side of that picture, you'd see where there's been a significant ingression of scrub and other plants from the hedge into the more herbaceous part of the verge, which meant it would be difficult to harvest that with a conventional harvester. And we then, using an average of the data from Powys, we produced some data for harvest. We converted the dry weight data from Powys to fresh weight because the other thing that we become interested in is the sheer logistics of moving this stuff about, bearing in mind you're going to cut it and take it away probably in one go. We've had a number of lengthy discussions with contractors now, and their view was, both from the AD operator side and also from people who harvest this or cut this material, that if you're going to harvest it, to make a meaningful harvest, you could probably widen the cut width to 2 meters. And that's what we did. We then played with the numbers and adopted an average based out of these, not a 485 but a 450. It made the arithmetic a little bit easier. What we then did was to look at an AD performance model. This is a theoretical anaerobic digestion system, but based around some of the smaller to medium scale plants you'll find on farms throughout the UK. We looked at 2 types of plant, a standard twin tank, there's a picture of that in a minute, and also a single tank, which is a plug flow. And both you would find in rural situations. We modelled it on something with about a 200 kilowatt electrical capacity. It would also produce about 300 kilowatts of heat as well, if it's running the gas through a combined heat and power. And we modelled it using a number of different mixes. One of them was a 4,500 tonne of biomass from the verge and 1,500 tonnes of energy crop maize, and we looked at another version with the proportions almost reversed. And it wasn't that discouraging. A twin tank, probably a 5-year payback, although I have a suspicion now that with some of the changes that the government have recently been mooting that they will bring into support for renewable energy, that those figures might become a little bit more challenging. But there are also a lot of AD plants already in operation who are becoming more experienced and could well decide that they want to have a look at that. We assumed a gas yield for the grass of about 120 cubic meters per fresh weight tonne, and boosted by the energy crop maize. And we also assume that some value could be realised from the use of some of the heat and the digestate fibre for briquette fuel. So that did contribute to these fairly encouraging looking turnaround figures. But of course it lengthens the number of assumptions, and these are discussed a little bit more in the report. For anybody who's not sort of seen this kind of kit, that's a small scale twin tank that would be about the size of the 200 kilowatt. Very briefly, with anaerobic digestion, material arrives into the shed like that. It's shredded, it's pumped into this tank here, which we call a hydrolysis tank. And this tank, it starts off in a very acid medium, and then as it's stirred and moved up the tank, it becomes somewhat more alkaline. The hydrolysis breaks down the long sugars and starches and available cellulose. At the top of the tank up here, you start to get a bit of methane producing as different bugs take over, and in the top half of the tank you start to steadily pump the material into a bigger tank. Hydrolysis happens quite quickly. In a matter of days, production of methane can take several weeks to get to an economic yield. So in most or in many types of design, you have these bigger tanks with flexible roofs that sometimes look like that, or they've been burning regularly in their combined heat and power machines. Sometimes it's become quite taut because they store methane in there until it can be pumped, until they want to pump it through to the the equipment where they'll convert it to electricity and heat. Just some of the kit that we use at the moment in Lincolnshire to deal with our road verges. We've got about 13,500 kilometres of rural road, of which this is one here, and this sort of kit is what gets used. 1.1 metre wide flail cutter to deal with the minimum cut, and in this instance a large 2 metre wide machine on the front. They just use that to do the safety swaths around junctions. Don't use it to cut the large quantity. This is what might start to be perhaps one of the replacements. These machines come from France. I've forgotten the name of the manufacturer who actually put these together, but some of you might have been with us in August, and we had one of these two machines on demonstration here in Lincolnshire, and we put it through its paces on some very tight, difficult little narrow, equivalent to lanes. They were actually on our university's farm campus, and it performed really quite a reasonable job. So we were really quite sort of pleased with that. Other machines are now being evolved because the marketplace for this is tending to grow. This is a Noromat in France. It's built on a Unimog chassis. It's got the advantage of fairly good road speed, so it can move fairly quickly. And the system they tend to use there is a caisson trailer which they can hook on, fill it up using the suction machine on the back of the Unimog. When it's full, they just drop it, the Unimog drives forward, hooks onto another one and carries on. It's quite efficient. The hesitation we have is it's quite a long machine, and because it articulates and is long in some of our windier roads and where we encounter bits of road furniture, it might be more of a problem, but it might be one that we'll look at. This machine is the one that we're at the moment focusing on bringing over to Lincolnshire next summer. It's made by a company called Herder in Belgium. Herder make quite a lot of specialist verge management equipment. Herder equipment is used in this country quite a lot, not with a suction kit on it, but to manage dikes and awkward to reach areas of vegetation. This machine is quite clever. They've taken the suction unit, and put it underneath the chassis, which shortens the machine considerably. This particular model has still got an enormous arm on it because it will go right into ditches and onto banks the far side. We are hoping we might have an adapted version of this that has an arm rather like that, so it shortens the machine down again, because that would make it more manoeuvrable on UK roads. It'll be a shorter machine. It'll be easier for traffic to negotiate its way around it. It does have a good road speed in operation, and it has a very good road speed when you want to move from A to B and then start to harvest. So we're looking to set up a trial next year, possibly with one of these performing with us. You've got there just a few other examples of the kit. There's our French machine in the top left-hand corner again, operating on a main road. They did have a keep left, or keep right rather, controller behind it. You've got there a version of the Noromat doing road verge edges, and here you can see why sometimes they have the very long arms, bottom right-hand corner, with the arm fully extended and actually clearing the material out of verges beside a motorway. The power of the actual suction and blow system does compress the grass a bit, so you get a reasonably good dense amount of material in the back of the machine afterwards. This one employs a walking floor to just walk the material out and stack it. And this was at a French anaerobic digestion plant, where afterwards they were pushing it into a big clamp and ensiling it before use in their anaerobic digester. This is an example of an operation, I think this is on a military airfield, but I saw an even bigger version of this in Germany, dealing with all the grass on Stuttgart Airport. There are some other possibilities. One is integrated biomass feedstock management. I mentioned earlier we've been in discussion with partners in Europe, and this flowchart here indicates where we're using the grass coming into a centre that might also be collecting a range of other landscape management arisings, anything from shrub clearance and hedge management through to large-scale arboricultural arisings coming in. And the system here talks about using something called the combine IFBB process. For those of you that haven't come across this, in Germany there is a plant based around an anaerobic digestion operation, but there what they do is to wash the grass that comes in. They shred it, they put the liquid into the AD plant, the heat from the AD plant they then use to dry the fibre, and they mix that fibre sometimes with some of the other very coarse material, and they crush it to form briquettes. Their view is that the washing of the fibre actually removes certain things that otherwise give rise to impurities in combustion gases when you burn the briquettes, but they produce a briquette that's very dense and acts almost like a timber-based briquette. So if you were looking at an integrated thing, you may want to be looking at a range of partners. We've certainly already started talking to inland drainage boards as well as local highway agencies. We've got some potential partnerships that might develop with MOD as well. In other areas, there will be lots of other partners. Local wildlife trusts, RSPBs, major managers of nature reserves. Small scale AD, that's using AD smaller than that which I've already described, but produces power and heat to drive this fibre drying stage. Now, the possibilities with that do come with a few health warnings if we're going to go down this route. Micro AD as a standalone on its own might not be viable in terms of the energy that it puts out in relation to the capital expenditure that you have to put in. There are some possibilities, I think, though, if some innovative thought processes get involved in it, within the charitable sector where you might be able to attract other forms of grant or funding to mitigate the capital costs of setup. Although Treasury has just announced, unfortunately, that Enterprise Investment Scheme funding is going to be withdrawn forthwith, even for charitable sector renewable energy projects, which is a shame. There are discussions around whether one could use volunteers to help subsidise aspects of the harvesting of the biomass, and if those volunteers are linked to a community energy project, then that may both increase funding and energise interest in the fuel produced. And that just happens to be, some of you may know this, an example of a micro AD system operating in this way in Scotland, with biomass coming in, being shredded, it's screw pressed, the liquor goes into an AD plant, and the heat and energy is then drying this to produce high energy fuel briquettes. So where are we at the moment? We're now, as I've said, starting to evaluate cut and lift systems to see if we can compare their performance with the key performance indicators that local highways contracts will require. And we're looking to carry out a field study to assess the range of fresh weights that may well be available. We're looking to assess the methane gas potential of the fresh and ensiled biomass, and we have had our first sets of results from some preliminary samples, which have been very encouraging indeed. And we've had one meeting with a network of AD plants that now could well be interested in getting involved in the next stage study, which is quite exciting. Oops. We're also looking at the feasibility of establishing a locally designed cut and lift unit, and those discussions are ongoing at the moment. There is a bit of a concern that that magnificent herder machine that I showed you earlier is built to take all manner of stuff, and is probably slightly over-engineered for a specific road verge grass or herbage harvesting operation. Like all these disruptive ideas, there are some issues. One thing is the potential for large-scale variation in the distribution of virgin biomass. Whether that will cause any issues in the cost base for the supply and processing through an annual cycle is something we're going to be looking at this coming year. So we feel we'll have a really good handle on that, certainly in lowland situations, and there are other people who are going to be able to come in with information on upland situations and situations on the west side of the UK. I don't think that's as big an issue as some people thought, and it feels to me like less of an issue than when I started on this work. There is some discussion about whether repeat harvesting of verges could result in an overall decline in the volume of feedstock. Some initial data in the Combine project from the UK implied that this was the case, but actually the sites that data came from were upland degraded wetland sites, and what they were harvesting tended to be soft rush, a little bit of bracken, in other words invasive species, which in fact tend to decline with mowing anyway. Some other data that we have been looking at with lowland grass areas did indicate that the species changed, and in some respects the species numbers went up, so the herbage nature changed, but there was much less indication of a major reduction in the volume of feedstock because of mowing. But we're going to have to keep an eye on that. We don't know enough about what the fibre that comes out at the end of an AD plant after using this stuff will be like. There is a possibility it might emerge from a dewatering process as a slurry, and if that is the case, it may be difficult to use that for briquetting. However, other research that I'm involved in may mean we could use it instead for turning into a compostable material for horticulture. And the issue of contamination of grass verges and its status for permitting are a subject of ongoing discussion with the EA, but I'm sure we're going to be able to work our way through that. And finally, really, Why are we doing it? Well, there's an increasing interest in looking at new types of feedstock, driven by some of the things that we talked about at the start, and also anaerobic digestion operators are now becoming a little bit more confident in looking at how to develop flexibility in the feedstock that they use. That came across very clearly in a meeting that I was at on Monday. This could well produce an additional source of income from the rural landscape. It may help, and it should help, overall carbon emissions. It should help us to drive biodiversity forward. And if in a place like Lincolnshire, where we have lots of good nature reserves, but many of them are dangerously isolated, if we can connect them through a network of biodiverse corridors, that would be brilliant. Thank you very much indeed. I think I've done me half an hour, so I look forward to any questions. Thank you very much.
Hi there, Nick. Thank you very much for that.
No problem.
I certainly learned something. And I'm a big geek. I love any big machinery like that. The one you were saying, did you say it was a French design? Is that one that you have been brought over from France?
In the first slide of the two machines, the slide bottom right hand corner, yeah, we had that actually in operation. In fact, if you go onto YouTube, I think you can find a very, very short clip of it munching its way through some undergrowth.
Great, and that's also really good, I think, to mention that its speed is roadworthy, to kind of help promote doing this work and you know, not alienating the local community. That's fabulous, and it's good to see new technology, modern technology, and the right amount of funding in work such as this. Because often, especially with local councils and things, that's, you know, that's often what we hear. Often the problem, funding, allocation, and, you know, wanting to do the work, having passionate people, and not having either the time or money as the main causes.
I mean, I think
resources. That's great.
It's quite interesting that there are some opportunities beginning to emerge to be innovative. I'm sure some people will know all about the wetland biomass to bioenergy project, which has been working. It's a DEC and DEFRA funded project, and that's about a bit like this, but it is actually working on wetlands, where it's very difficult to take machinery anywhere. And one of the best machines that's emerged there is a British designed piece of kit. And we've looked at it in relation to this project. While it of itself is not really meant to work on roads and doesn't work on roads that well, it's a soft track machine. It's got some really clever features that I think we could adapt onto another tool carrier, which would make a really efficient UK-based machine worth doing. And it's interesting to point out that the marketplace for this sort of machinery isn't small. We reckon that you only need 700 or 800 of these machines operating across England and Ireland if you were to take this on. But they would be producing, you know, anywhere between 2 and 4, when you take Ireland into consideration as well, between 2 and 4.5 million tonnes of biomass a year, which would actually light up a couple of small towns.
Yes, that's exactly my thought. And it's good you just mentioned kind of an adaptable machine that could be either retrofitted or adapted for a different tool use. And that, again, cuts down the amount of machinery needed, therefore the amount of money needed, and storage space and transport, so logistics issues. So that is fantastic. Please do chime in, anybody, if you do have questions for Nick. I'm kind of obviously very, very well versed there, very well explained all your points. So actually, if you pondering like me, I always kind of come up with loads of questions about an hour after the webinar when it's sunk in, when you're having a cup of tea. So if you don't think of a question now, you'll be sent a feedback form 24 hours after the webinar. So there'll be a mental jog for you there to send in anything you may have thought of. I'll just give you maybe one more minute if you'd like to ask any questions. It's funny, we do these webinars every week, and some people flood in with questions, and some just kind of go, yes, that was really, really interesting, and I've learned lots, but I don't have anything to add. So
Well,
whatever's fine.
that's
As I
not a
said,
problem. What I will do is if you remind folk, if they'd like a copy of the report from which I just picked one or two bits, that goes live next week on Monday. So just connect me with them or send me a prompt, and I'll make sure that the report's available, because we would like some feedback on that.
oh, wonderful. Okay. It's also, we might be able to put that on the website.
Yes.
Underneath the past webinar section. So
Yep.
that's what we'll do. If you send that to me on Monday, and then we can upload it. So if you go onto our website section of the LI website, then we'll have past webinars. It will be listed here. We can attach that document, and then they'll have a link to this recorded webinar on YouTube. We have a question in from Simon Adele, who actually works at the LI, and he's tuned in from elsewhere. He's off-site, and he's saying, could you say a bit more about the Combine project, Nick?
Yeah, Combine was behind that complicated-looking flowchart that I stuck up on one of the slides. It's it's just finished its program now. It's a multinational Interreg-funded project, and it was looking at the possibility of using an approach rather like the one I've just been describing, but not specifically for road verges. Their interest is in road verge, but everywhere else that landscape management is producing material that then needs to be dealt with subsequently. And more proactively than that, one of their key partners in Eastern Europe, called Danube Energy, are really interested in addressing the agendas that they have out there, which is around land abandonment, where people, especially farming on relatively marginal land, are not farming anymore. And what's then happening is that where that land had quite substantial areas of wetland, some of the wetland is now turning to scrubland. That scrubland doesn't hold water back in the way that the wetland does. And the big issue that they are becoming very exercised about is flooding further down the Danube. With, you can imagine the catastrophic consequences of that. In fact, we've seen it once or twice on the television in the last several years. So they're looking at really large-scale landscape management projects linking to running large-scale power stations off material such as we've just been talking about here. So we're not necessarily talking about anaerobic digesters. We're talking about turning it into large-scale briquette manufacture and then putting that material into fired power stations. A bit like Drax burns biomass now instead of coal. A similar situation there. And there are other parts of France looking at it from the same point of view, because they're worried about pollutants, especially when the grass rots and gets into ditch water, running into aquifers. And that actually drove one of the local authorities to take on the sort of equipment that you saw me demonstrating on the slides earlier on, because they have an issue with Evian water getting contaminated by nitrates, which they track back to this sort of thing.
Okay. Well, by the way, just to add, Simon did put underneath, he was aware that it wasn't your project, but he just thought it'd be interesting, the idea that bracken could be used.
Yeah, well, I mean, that's another one that is something that I referred to. I've talked about AD, but there are 2 or 3 technologies that I'm now getting involved with where they can take this material and they put it through a different process, the end result of which is probably bioethanol in one case, but it can also be a range of different gases for the chemicals industry in another case, that would quite happily use material like this. In fact, the bioethanol one will cope with the range of materials that I refer to in that flow diagram, not just grass and road verges, but it will take forestry arising, it will take green bin waste, and the potential yields of fuel look very exciting.
Okay, fantastic. Right, I'm just going through. You've already answered one of the questions, so that's fantastic. And if there's no more, I think we're wrapped up for the day. So just to reiterate that this will be going on YouTube. So don't worry if you know of colleagues that have missed it. We'll share the link. It'll be under the webinar. on our webinars page of the Landscape Institute's website. Do feel free to send in any more questions if you have them. And if there is nothing else, then I'd just like to once again thank Dr. Nick Cheffins for that fantastic webinar today. I've learned a lot. I'm sure everybody else has. Very well presented. So have a good rest of your afternoon. Wonderful. Have a good rest of the day, everybody, and see you again next week. Thank you. Bye.
Bye-bye.